morning, everyone. Thank you for joining us today. I'm Elena Yon, account trainer for Europe, based in UK, London, here at Geotab. This webinar today culminates our initial UK series of 6 presentations. You will be able to access all of them on our YouTube channel, and I invite you to do so. And our presenter for today is John Kyle, Solution Engineer here at Geotab. He will be speaking about cost control strategies and the tool that Geotab can offer you to optimize your expenditure. And with that being said, I'm going to hand over to John to get started. John, over to you.
Thank you, Elena, and good morning, everybody, and thank you for joining the webinar. As Elena said, my name is John Kyle, and I am presenting this webinar on cost control strategies with Geotab. Just a little on my background before we kick off here. I've come from a transport industry background myself, and I've been working with telematics now for on and off 17 years. I specialize particularly in driver behavior and engagement practices, as well as showing organizations throughout the globe on how to adopt and embed telematics into their business. So let's begin. In this webinar, we would like to address 2 major objectives. Firstly, all those who are already working with Geotab, and many of you are, we will be seeing some strategies that enable the organizations, or end users even, to achieve a more efficient operation and therefore reduce the total cost of ownership, or TCO. So we need to know the cost control strategies to reduce the total cost of ownership. For the correct calculation of the total cost of ownership, however, we must take into account the following costs that occur with it: maintenance costs, insurance premiums, fuel consumption, accident costs and claims, as well as the residual value of the vehicle. Also of great importance here is the way a vehicle is driven. This has a direct impact on the total cost of ownership, and driver behavior will be one of the key factors in this webinar that we address. In fact, the driver, and this is a quote you're going to hear me say many times, the driver has the single biggest impact on both safety and fuel economy in terms of driving behavior. And again, you will hear me say this again and again in this presentation. You'll be reciting it yourself, I think. This statement is very true, and there is definitely a need for adopting a good driver engagement strategy within the organization. Secondly, for all those who are considering making an investment in telematics, the strategies that we will see here can also be applied to calculate the return on investment of a telematics project, and therefore will help you make the best decision. So we will look into getting the tools to improve the way we calculate the return on investment. So let's start by looking at the 4 main areas where we will see strategies for cost reduction and where the impacts can be made. And these are the big 4: safety, fuel, productivity, and maintenance. So in this presentation, we're going to devote special attention to safety. And for me, safety has always been up front and first on the agenda. This slide now sums up why. As you can see, the area with the greatest scope for reducing costs here, contributing 40 to 50% of the overall cost, is actually safety. No pun here, but I drive the safety first message through every organization I meet. Moving on from that, we can see fuel contributes 14%, productivity 12%, and maintenance 14%. So safety improvements are particularly attractive because in addition to the costs, there is a very important human component here. We can't put a value on the health or even the life that can be lost, unfortunately, in a road accident. Therefore, if we improve safety of the fleet, we are actually fulfilling a double objective here. We're reducing a large part of the costs and at the same time, providing a much safer environment for drivers and actually other road users as well. Okay, just a few more stats here regarding the safety and occupational accidents. Again, we can see the heavy cost related to safety, 40–50%. So again, I reiterate, a big focus is on this area in this webinar, safety first, right? Over 30% of fatal accidents are related to speeding and aggressive driving behavior. In fact, this slide says 31%. So yeah, over 30%. On the seatbelt, despite all the campaigns and enforcement that has been carried out over the years, we still have a large number of injuries caused by not wearing a seatbelt. Wearing a seatbelt reduces accident risks by between 45 to 60%. Okay, so let's put this into pounds and pence. We'll talk about the costs. So although we have already commented that there is a non-quantifiable human factor here, such as the health or life of a driver, we can make an estimate, taking into account medical and rehabilitation costs, material damage, production losses, etc. So what we've got here is figures from the European Road Safety Observatory. And these are estimates. And as you can see, quite frankly, for me, staggering. A minor road accident averages £15,600, a minor collision accident. A serious road accident averages £207,000. And then finally, a fatal road accident averages 1.6 million. Incredible. I find these figures staggering, to be honest. Okay, so how are these costs distributed within an organization? And looking at these areas where costs can be impacted on, here we can see the reasons to invest in safety: a driver training program, engagement program, lost time due to work reorganization, vehicles and drivers redundant for periods of time is a result here. Insurance costs and claims. Here's one that I'm personally alluded to, because when I was actually driving a bus, I was actually involved in a fraudulent lawsuit claim against me for £250,000. A passenger was claiming whiplash. I had taken the wrong turning and reversed my bus into a streetlight, trying to do a 3-point turn, and didn't see the streetlight. It was camouflaged, and with the trees in the background, leveled the streetlight, and was called into the office a few days later, and there was a lawsuit coming in for 250 grand, basically. But it was telematics that saved the day. Telematics saved me. I was deemed to be reversing safely at 5 miles per hour. At no point in my maneuver did I exceed 5 miles per hour. So even though I leveled a street light, I was actually deemed to be reversing safely, and the case was thrown out. And it was telematics that actually saved the day for me. And this is when my eyes opened now to the value of this black box, is what it was known as, or spy in the cab, which was what it was commonly referred to. And it changed my whole perspective on actually what this can do. Moving on, vehicle downtime, we've covered that a bit. Vehicle repair costs, lower residual value of vehicles, loss of orders and business opportunities. Again, if you've got vehicles down, you're going to lose possibly orders or fulfill them. Damage to company image and brand. Again, if you're having accidents and you're well branded, you're going to be seen. It's going to be noted. Low morale, stress, and job satisfaction. Well, what I've noticed over time is drivers tend to be more relaxed when adopting a safer, smoother driving style. And finally, poor morale, which we've just mentioned, but this leads to a higher staff turnover. And this does incur further training costs, because if you've got a high turnover, you have to then recruit new employees, more driver training, more recruitment drive. It all comes with costs. Okay, here we've got a map of Europe, and this is actually the European map of road death per million inhabitants throughout Europe. These statistics here, these are actually from the European Commission website, so they're available. I've got the link in this presentation, actually, and they are available. But it is from 2017. It's the Mobility and Transport Road Safety Atlas per million inhabitants, road deaths per million inhabitants from 2017. And here, it's quite an interesting one. So you can see UK, Norway, Sweden, and Switzerland kind of like leading the way in terms of the least road deaths per million inhabitants. And then right over Southeastern Europe, yeah, you've got Romania and Bulgaria tightly knit together there, showing the worst. So just an overview there of how Europe actually looks in terms of road deaths per million. That was 2017. Okay, so as I've already mentioned, the driver behaviour is a key factor. And again, this is so very, very important. and I will repeat it. The driver has the single biggest impact on both safety and fuel economy in terms of driving behavior. It is the driver that is behind the wheel of the vehicle and in control of the vehicle. The wheel, the brake, the accelerator. So our mission will be to identify and analyze the risks associated with certain driving styles so that we can modify this behavior. This ultimately is what will lead to a reduction in incidents. Just again, some important stats. Over 1/3 of all road accidents in the UK are caused by drivers failing to look properly through distraction, tiredness, complacency. Many of the incidents happen at junctions where road traffic converges from various approaches, along with pedestrians and bike users, motorbikes, road bikes, approaching the junction with an appropriate speed, decelerating well in advance with a view to stopping will give the driver more time to look and observe. So with telematics, we can address this driving behavior by encouraging the driver to adopt a safer driving style. Okay, so the factors that we use to measure this and identify these risks, and in turn improve on the safety. Here we can see typically what is measured that can be used to influence better driver behavior and improved, safer, I say smoother as well, driving style. So speeding, harsh cornering, hard acceleration, harsh braking, engine abuse, or in other words, over revving. This is exceeding a certain level of revolutions per minute. After hours driving, even during hours driving, because you need to monitor that as well, and seatbelt usage. These are all indicators of an erratic and potentially unsafe, high-risk driving profile. And this is crucial because prior to telematics devices being installed, there was actually no way really of measuring these events. And now we can measure, and now we can manage. So this leads us now into what strategies we can use with Geotab to identify these risks. Okay, so the driving behavior report, which is what you're looking at now, is a very powerful tool. And for me, this is the most important report available in respect to safety and driving behavior, and actually even fuel economy, but we'll go into that a little bit later. Drawing from the harsh braking, the harsh acceleration, the speeding, the harsh cornering, the over revving, the seatbelt data, we can now create a driver performance score based on these, what we call exception rules. And we can look at the amount of occurrences, frequency of these rules being broken over distance and put together this driver performance score. Again, now that we can measure, we can manage. So this indicator is already alerting us that we have a fairly large margin for safety improvement. So if we can improve this and improve all the measures, which in turn has a positive impact on the safety and fuel economy in the fleet. So this report allows us to profile drivers in groups of risk levels, and thus we can easily recognize the safest drivers and also those with the highest risk. So we can focus and target this low-hanging fruit, which is what the high-risk area is. It generally is the low-hanging fruit. It's the area that can improve the quickest when bringing telematics into play. So, and this data. So we categorize here low risk, mild risk, medium risk, and high risk driving. So you can see that on the report there in the top right of the screen there. We have 40% of the drivers here in the high risk group. So that percentage is a good number to work with. It's a good percentage to work with because it's going to 48% to improve that will relate into a huge safety improvement and even fuel economy. So, but how we use this information will depend on the road safety or human resources policies that each organization has. Some ideas could be, for example, with this high risk group, would be to give a road safety course to the group of drivers at greatest risk, perhaps identifying, singling out some of the high risk drivers there and giving them one-to-one coaching, or give some kind of bonus even to the group of better drivers. So looking at the low risk drivers and possibly bringing in an adoption scheme or an incentive scheme, gamification as it's known as, that benefits a driver or collective group of drivers. And this can be very beneficial here to an organization. This is a very good way to get driver buy-in and increase the level of engagement. And adopting a good driver engagement strategy alongside this report does go a long way into improving driver behaviour and overall safety within the driving fleet. What I find is that the greater the driver buy-in here, the better the score, the better the safety. And with this report, you can reduce the risk. And also with this report, what you are doing is using it, utilising it. You are actually exercising due diligence. Okay, so that aside, now utilize this report, we can set goals now, targets. So again, we can measure, we can manage. When I first joined a bus company, I asked, literally as soon as I walked in the door, how often were the drivers appraised? And the answer I got was never. There's no way of appraising drivers on the road. They're on the road, they're in a bus. We don't know what they're doing. We can't measure them only in terms of how many reported accidents they've had. So the driver was only seen when they had accidents, as in my case, when I had the accident with the streetlight. I was seen once, and thank goodness only once. But that was the only way you could measure a driver. How many accidents did they have? That was the appraisal, basically, but they didn't get one. And this was prior to telematics. Now, telematics is there. Now the drivers can be, and now they are appraised. So now that there is a measure, the driving standards can be actually managed. So this report perfectly sums up how telematics can now play a part in delivering actionable data. So what the organization can do now is set the key performance indicator. There is a KPI for the organization in terms of driver behavior and performance. So the organization now can set the driving scoring standard by benchmarking the good driver score. So look at the low risk scores, average them out. What are they? That's the standard. That becomes the KPI. And this standard can be used to assess a new driver following the probationary period as well. So, you know, when a new driver starts, there's a standard that the company has set. And after 6 months, that standard has to be reached. After 6 months, would you keep on a high risk driver? So this is a very useful report for not only managing performance and safety moving forward, but actually encouraging new recruits, new employees into driving better from the off. So starting to analyze driving styles, we will definitely begin to improve on accident rates and even fuel consumption. Again, we'll come to that later. So smoother driving, less emphasis on the harsh braking and acceleration ultimately leads to fuel savings here. But we cover this later in the webinar. Okay, I did mention gamification or incentivization. It's becoming very popular. It is a strategy that fits very well within organizations where the previous strategy, say, of profiling drivers is perceived as intrusive. Again, that black box, that spy in the cab scenario. And often, yeah, unions are against it, but bring in a form of incentivization for the drivers, gamifications, it helps greatly. So some tips for implementing gamification. Clear targets can be set. For example, here we've got a 3-month example, a 90-day period where the target has been set. Reduce speeding by 45%, improve seatbelt use by 10%, reduce harsh braking by 30%. These are targets that can be set because what we can measure, we can manage, so we can do this. And then what's important is not to stay static there, to keep moving. Constantly review after that 90-day period, review, revise, and keep moving. So push, push, push. Okay, but keep the targets realistic. And of course, yeah, offer rewards to the winners so that there is motivation and create a competition atmosphere. An element of peer pressure can also help further buy-in here with less reluctant drivers, less willing to participate. You find that drivers who are less willing to get on board with this scheme, they do get kind of pressured into taking part, especially if they become included anyway, like it could be a team reward. So in terms of rewards for the winners, there's no right or wrong answer here. It could be cash prizes, it could be a team day out, a night out in a restaurant, tickets to the cinema, free tea and coffee for the winning depot. So you could have like an in-house competition if you have various depots pitted against each other. The important message about incentivizing here is it's all about attaining the driver buy-in and getting a good level of engagement throughout the driving team, which is essential. You know, you need the driver buy-in and you need their engagement. So a good strategy here is important. Okay, so what we've got here is, I'm sure you've all seen many graphs over the last few weeks, and I'm tempted to say flatten the curve here. But what we are intending to do here is, you can see through gamification and an incentive scheme being adopted, what we have here is the typical measures: the hard acceleration, the harsh braking, the harsh cornering, the seatbelt, the speeding, and in this case, idling. We've brought idling in here. I'll talk a bit about idling later as well, by the way, because actually there is a safety message with idling, and I'll allude to that much later. But what we've got here is the frequency, the number of what we call exceptions. So the harsh acceleration, the harsh braking, the harsh cornering, they're set at levels, and when triggered, they create an exception or an event, so to speak. So we can see how many events of each of these has happened in a week. And the object is less every week until you, I'll say flatten the curve, until you get down towards that zero. And ultimately, that's what this graph you're looking at has achieved over a period of, I think that's 11 weeks or so, and all the events have actually come down. Okay, so skill reinforcement is a very effective strategy for reducing risk behavior. And with the Go device, it's connected to the OBD ports, and we can notify those events that we just laid out. They can be set up to notify with sounds or beeps. In our Geotab platform, we can configure under which conditions we want the device to emit these beeps and alert the drivers that they are violating some road safety rules, such as speeding, or they're harsh braking excessively, or harsh acceleration, harsh cornering, over revving, seatbelt, they haven't put the seatbelt in. So that becomes an audible alert. So what we've got now here is in-cab coaching, and it's real time. And all these events, these rules, can be customized to the organization's needs. What you've got to bear in mind here is that for this strategy to be effective, and I've come across this a lot, it's important to limit the number of conditions for which we alert the driver. Because if the driver generates too many alerts, the driver will end up not paying attention to them. It'll lose its effectiveness. If you've got too many alerts going off, it's going to get on the driver's nerves, really. But then again, the driver does have to play that part where they're reducing the number of those beeps, but they have to be achievable. So particular attention is required in implementing the appropriate levels of G-force on these events. Not too high, but not too low, because you can have too many alerts, but also on the other side of this, you can have too few, and they will not impact any driver behavior at all. So it is important here to set the alerts at an appropriate and achievable level. And moving into the collision and accident reconstruction, which is what you can see here. So this is useful as well. This module allows us to generate a detailed report to reconstruct the conditions in which an accident or collision has occurred, so we can understand what's happened. We have information such as the exact point of impact here on the vehicle. We can visualize the vehicle's path on the map, and we have available all engine data such as speed. We've got the RPM, we've got the acceleration, the deceleration. And all this is very useful to complement the verbal testimonies of the people involved in the accidents. This information can be used to enhance driver road safety awareness course programs. I haven't been on one myself, but it's data like this that the police use, or training courses use they display accidents and show the data behind them. In this particular case, obviously the data would be anonymized and only used as an education piece. But it is important to understand the reason and cause of accidents, so we can go some way to preventing them. So great piece of information here, and it's a very useful module in the Geotab platform. Okay, this is all about the privacy and the personal mode, which is quite a sensitive topic, privacy. What we have here is drivers will always have the possibility to put their vehicle in personal mode. And the geolocation of speed and the data associated with that will not be recorded. So the geographical positioning, the speed of the vehicle is not displayed in personal mode. Geotab offers different ways to make this switch from professional to personal mode and vice versa. So it can be done manually on the platform. It can be done by the driver via a mobile app, so you can manually just go in and turn it on or off. But it can be done automatically as well and set up to trigger within outside of working hours, sorry. So in this case, working hours could switch to personal mode at 6 p.m. in the evening or 5 p.m. in the evening, and the vehicle switches to personal mode then, and at 9 a.m. at work start, it switches to professional mode. So it can be set up automatically. With that, that's kind of safety all covered. And we now move into another area, which we started off discussing at the start, which was fuel consumption. And this has potential cost savings up to 14%. The Geotab platform accumulates a huge amount of data related to fuel consumption. So now, we can ask the question, how can we analyze this information to enable us to make cost control decisions and reduce the fuel consumption? So what the Geotab platform allows us to do is convert the data into graphs orientated to make it easy to analyze it in a more visual way. So here, for example, we can measure fuel consumption over a selected period of time, week or month, and we can now look at that, look at the vehicles in more detail in terms of how it is being driven, or are there any engine anomalies that could be causing poor fuel economy. This could be grouped as well by vehicle types. We can look at which vehicle types are giving the best fuel economy, and that itself is a very good procurement aid. We can analyze the trend of the fleet's idling time. If this trend is upwards, we should be taking corrective action to contain that cost, and we'll move into that again later in the presentation here in this webinar about idling costs. We can also check whether the fuel consumption is consistent with the distance traveled. Generally, there's a relationship with distance and fuel, and that becomes clear when you're trending. And again, trending the fuel consumption is good as well, to highlight that for seasonal variances as well. And we've got here as well fleet driving habits, and that has a direct impact on fuel consumption too. So this is referring to exception events, etc., that have been triggered. So for example, it could be the harsh braking event, could be leading to poor fuel consumption. And this actually, harsh braking does have a massive relationship with fuel consumption. If you think about every time you harsh brake, how many times you do that on your journey, every time you brake, what's the next thing you have to do? You actually have to accelerate and put more fuel in to regain that momentum of the vehicle. So if you can imagine this in a heavy goods vehicle, every time you're braking, you're going to have to put in a huge amount of effort to get that vehicle moving again, and that is fuel. So braking has a direct impact on fuel economy. So again, it's all about that balance between the harsh braking and the harsh acceleration, and getting that smooth driving pattern and improving those driving habits. Harsh braking plays a huge part in this. Here we've got fuel transactions. This is an interesting strategy. If a fuel card is being used, so on the platform, in Geotab's platform, it has the capability to detect discrepancies between the refuels registered on the card and those registered by the Geotab's telematic device. So you can see here we've got the telematics device fill up and the imported fuel transaction that took place, and there's a comparison. Fuel card transactions can be automatically loaded into the Geotab platform as well, allowing for analysis and detection of possible fraud. So that is a useful tool as well. So moving into maintenance, which is another area where we can find costs that we can control. In fact, maintenance was up to 14% in terms of cost control there. So for example, with unscheduled maintenance alone, we're estimating losses of between £400 and £700 per day without taking into account the cost of repair. So we're going to look now into two strategies to contain this cost. So my Geotab offers, again in the platform, a very simple way to schedule maintenance by time or mileage. So you can set up, kind of like the exception events, you can set up a rule, a reminder rule, that's triggered after so many months, after so many miles. And that can be for a list of a vast range for anything from service, MOTs, oil changes, lease expiry, etc. So therefore we can take this into account in our planning. And moving down there, we've got the pending maintenance reports, allowing managers to always be aware of vehicles that need to be serviced, that's coming up for lease expiry, oil changes. And in this particular example here, you can see we're being alerted to a vehicle. So this is at the bottom of the screen there, the bottom right. We're being alerted to a vehicle that requires an oil change and 2 vehicle reminders that their leases are due to expire. And this will help the organization to plan effectively, schedule when their vehicles need to be coming in, and just maintain overall operational efficiencies, basically. So again, very useful at helping and maintaining maintenance costs. This is a topic I'm familiar with as well, very familiar with. Another strategy is preventive maintenance, which allows us to anticipate breakdowns thanks to the information we obtain through the OBD pod, the diagnostic codes and associated with that engine rules. So these diagnostic codes are DTC warning codes, I think is a term used. These diagnostic codes identify which vehicles are being driven with the fault light on and can also be used to schedule maintenance or prevent serious engine damage. Engine rules, you can see, I think an engine rule there is on the right of the screen, kind of in the middle. An engine rule there has been set up to alert and push out when it's triggered. And there's a really good reason for this. And again, it happened to me. So it's so common for vehicles to display an engine warning light. I mean, I used to go into a depot and get on the vehicle and the engine warning light was on. And, you know, I would say the engine warning light's on and I would be told, don't worry about it. It always comes on. It's always on that vehicle. And it kind of created the boy who cried wolf scenario. And actually what did happen was en route, I had a massive engine failure. It did actually happen. And unfortunately, it's too late. It's been on too long, that light. It's now developed into catastrophic engine failure. If that engine warning light had been dealt with when it first came on, it proactively could have been avoided. So drivers tend to kind of, if it's not their vehicle, they're not so concerned. But what we need to do here is we can create this rule that proactively helps you manage the fleet and reduce that engine damage and wear and tear. We can detect fault codes as well, just as a garage would when it connects into a diagnostic system, something very useful, you know, thanks to the information we have about the battery voltage. So we can predict days or weeks in advance when it will fail. But normally the battery gives out signals when it falls below 9 volts. And with Geotab, we can easily set an alert to warn when this condition occurs. So preventive battery maintenance here. Also look at the duration and lengths of the trips in relation to battery voltage. So this is important as well, because often vehicles are maybe in a fleet, they're just doing short trips, very short trips, like your postal delivery companies. They will be down the street and stopping 5 or 6 times, and then going to the next street, stopping 5 or 6 times. And that's the pattern. And they stop, and they only do a few miles. That actually has wear and tear and runs the battery down. And that can lead to a non-start. So looking at vehicles and the length of trips can help. So running a mileage report with this to ensure that some of the vehicles are getting a good run out every week and not just doing these constant start-stop trips. Okay, so we move on now to look at productivity, which is the 4th and final area where we're going to look at the cost control strategies here. And this is up to 12% cost savings available. Just as we've done with fuel, the aim here is to convert the vast amount of information we have in our fleet into graphs that will enable us to make decisions easily. So for example, it can be useful for us to know how long the vehicles stop during their routes. Optimizing layover times help reduce costs here. Looking at the distribution these stops have, for example, how much time they spend at base, how much time they spend in customer offices or at delivery sites. We also know what percentage of time the vehicles are used in personal mode, analyzing distance and driving time. This is important as distance increases significantly. or driving time starts to increase significantly, it may mean the need for fleet expansion and schedule adjustments. Alternatively, it can go the other side, the other way. If mileage significantly decreases over time, over weeks, over months, it may result in downsizing the fleet and again, rescheduling the service. We've got a trip density graph, which can give us clues about patterns related to which days there is more or less fleet activity. This is useful for planning vehicles in for servicing and maintenance. So the lighter days, you would schedule a chunk of your fleet in that. You'd look at your service reminders, what's due in for servicing. You could plan to get these vehicles in earlier if necessary, planning driving hours around it as well and costs related to that. So trends can be identified, especially for specific times of the year. The asset utilization reports as well. These are very, very useful. You can identify the most used assets and the more critical assets to the business, and what are the underused vehicles that could be used or outsourced elsewhere to aid productivity, or therefore even lose the vehicles, just get shot of them and reduce the vehicle costs over the course of time. And now we come to idling, what we can measure, we can manage, and idling affects productivity, and for sure it incurs a fuel cost. Idling consumption is about 1 litre of fuel per hour in a standard vehicle like your car or van, moving up to 3 litres per hour if it's a HGV or bus and coach. And as you can see from these calculations, with a fleet of 50 vehicles that use, say, 20 minutes of idling time per day, we would be idling at a cost of almost £6,000 per year. If they were trucks, you'd have to multiply that figure by 3, as they would be 3 litres per hour. So now you can get a picture of your idling trends of your fleet. So from Geotab, we recommend 2 strategies to contain this expense. On the one hand, we can set up a rule on the platform to directly warn drivers when they exceed certain idling times. And there you can see the idling rule there on the screen at the bottom. It's very simple. It's you edit and you can just adjust the length of time you want the idling to trigger from. So if it's over 5 minutes, the idling rule kicks in. It's very simple to do. On the other hand, we can generate a series of reports now and graphs so that the person in charge of the fleet manager, has this relevant information of the idling time of each vehicle or the entire fleet. Geofencing the idling areas and targeting these zones through detailed daily reports. As you can see here, we can estimate what all the idle time is going to cost. We know the duration, we know the cost of fuel per litre, we know the typical idling burn rate. As I said before, it's 1 litre in a standard vehicle or 3 litres in an HGV. So we can look at the daily, weekly, monthly trends in these idling times so you can make decisions if you see abnormal consumption. In hot weather, you can expect air conditioning to be almost continuously running. So engines will be continuously running. Fuel economy will be impacted. So in hot weather, you're likely to see your fuel economy impacted here because the aircon's going to be permanently running. Likewise, in cold weather, the heaters will be on, so engines will be running. So look at the trends, plan for the weather, and knowing idling costs may be incurred because of extreme weather. This can help planning and budgeting. So some fleets, I know this, some fleets in cold sub-zero temperatures will actually start up their engines earlier in the morning ahead of run out. And this is simply to avoid a non-start with an engine brought on by sub-zero temperatures. So excessive idling in a large fleet will mean a greater fuel cost in extreme temperatures, perhaps. And I did say that there is a relationship between idling and safety. And I've come across this a few times as well. And it's very interesting, but when a vehicle is idling and left unattended, it is actually at the greatest risk of theft. Very interesting. Now, I've seen it. I've seen delivery companies where their vans are stolen because, again, down a quiet street, engines running, they have 4 deliveries to make. The houses are quite close. They can nip out. It's a warm day. They leave the aircon on. They walk. They run down the street, do the deliveries. In the meantime, the van's gone. And, in the UK, it's quite common what we all do in the morning. We get up on a frosty morning, we de-ice our car. Some of us don't have de-icer and they're a bit lazy. We go out, turn our engines on, let the car warm up with the heaters on while we go in and have our breakfast. And that's when your car gets stolen. So there is actually a relationship here there. So we're coming towards the end now. I just want to summarize everything we've seen in the last few slides. So we are living in a complex and uncertain economic environment, and fleet managers are under great pressure to reduce costs. So managing a fleet that does not exploit 100% of the potential offered by telematics is very likely to lead to increased costs. And I'm very passionate about this. It's so important to use to maximize this data. And in Geotab, we have 20 years of experience in improving the operational efficiency of fleets, and we hope to help you in your next projects. And my message to everyone I meet is, please use the data. It is there, it is yours. You can now measure, so you can now manage. I would like to thank you all so much for your time with this topic today, and now hand you back to Elena, should there be any questions that we have to answer.
Thank you very much, John. There is a question from Andrew Pierce from Level. Please, could you let me know what fuel cards integrations are available?
Okay, I'd have to get that information. I haven't got that to hand, but I can pass that information on to Andrew. Happy to do so.
Right. So if a driver has selected personal mode and then has an accident, how can you recreate the accident report if miles per hour route is not captured?
Okay, so the data is there. It isn't shown, and a request can be put in. I believe a request can be put in to Geotab, and a process can be established to look at that.
Yes, so just to clarify, the question is, can we get that information if the driver has selected personal mode?
I believe the information can be attained through special request, but there is a process to go through, especially if it is a severe accident. Initially, there is no GPS data or speed related to that event. If engine data is available, we can do this.
Okay, thank you, John. Another question from Patricia Delgado. Hi, John, ET, is it possible to get mobile alerts about driver behavior or accidents via a mobile phone?
To my knowledge, we can push out data to via email. I believe SMS can be done.
We've got another question. How do you measure actual downtime / uptime management, especially on commercial vehicles?
Yes, through a trip report, you can do that, because you know when a vehicle is stopped, when a vehicle is moving. So you can have downtime and uptime, yes.
Okay, thank you. The next question is from Marisa Shear from Shell. Do you have any advice how to speak with the unions about introducing telematics and driver behavior scorecards?
So absolutely. So the way to go about this is, and I found it most helpful, is full transparency. So from the start, before you do anything, involve the unions first. Okay, so when a business is looking at telematics, they must also invite the unions, get them on board from the start and show them the value of it. Especially, I alluded it to my experience when I had that accident and I was exonerated because telematics exonerated me. So show the value of telematics and how it benefits the driver, get the unions involved, show them the telematics, show them what it measures, and get them to agree even the levels of the settings for the events themselves, for the exception rules. I work with the unions and take them out and get them driving to establish what those settings are. So I get the union buy-in first with that scorecard. And if they can drive it with the scorecard and drive it well, then generally the unions are happy. And again, it's all about what I said at the start, safety first. So it's all about the safety scorecard. And when you're talking about safety and unions, you've got to ask, what is the sole purpose of the union? And the sole purpose of the union is the unions are there to protect the interests of the employee, and what is of no greater interest than their lives and safety. So fundamentally, that's where I start.
Thank you, John. Can the system offer route optimization to maximize a fleet?
Yeah, we do have route planning. You can go in and put your routes in. We do have that. So effectively, yes, you can set up your routes, your optimum routes in the system. Yeah, that's there.
All right. One more question. A lot of the major telematics suppliers in the UK have ROI calculators available for sales team to present savings to their customer. Do Geotab have such calculator?
Geotab are producing a return of investment calculator is being produced. I'm actually working on that with the global team now, yes. So one will be available.
Thank you very much. That's all we've got as questions. We will close our webinar here. So please just be reminded that you can access all the sessions on our YouTube channel. Look out for a new season of webinars starting next month. And I apologize for the crackling noise on my end, and it must be probably the internet connection. With that being said, I just thank you very much for attending. Thank you, John. Have a lovely rest of the day.